What really happens if you enter space without a spacesuit? Imagine you're floating outside a spacecraft. Suddenly, your spacesuit fails. Within seconds, you're exposed directly to the vacuum of space. Would your blood instantly boil? Would your body explode like in the movies? Would you freeze solid? Hollywood has shown us terrifying versions of this scenario for decades. But the real science is far more fascinating and much stranger. Today, we're breaking down exactly what happens to the human body when exposed to the vacuum of space, why your blood doesn't actually boil the way most people think, how long you would remain conscious, what NASA and space agencies have learned from accidents and experiments, and whether survival is even possible. Part 1. Understanding the vacuum of space. Before we understand what happens to the body, we need to understand what space actually is. Here on Earth, we're surrounded by atmospheric pressure. At sea level, the atmosphere presses against our bodies with tremendous force. We don't notice it because the pressure inside our bodies balances the pressure outside. But in space, there is essentially no atmospheric pressure. The vacuum of space is almost completely empty. No air, no breathable oxygen, no atmospheric protection, no pressure support, and this lack of pressure is what creates the real danger. Serious, not freezing, not burning, pressure loss. Part 2. The big myth: your body does not explode. One of the most common myths is that a human exposed to space instantly explodes. Movies love showing astronauts bursting apart dramatically. Reality is very different. Human skin is surprisingly strong. Your skin and connective tissues can withstand significant internal pressure. Instead of exploding, your body would begin swelling. The gases trapped in your tissues expand. Your body could inflate to nearly twice its normal volume. But your skin would largely keep everything contained. You would look swollen, but you would not burst. This fact has been confirmed through scientific research and accidental vacuum exposure incidents. Part 3. Why fluids start to boil. Now let's discuss the most shocking part. People often hear that blood boils in space. This statement is partly true, but it needs explanation. Boiling isn't caused only by heat. Boiling occurs when surrounding pressure becomes too low. In space, pressure drops dramatically. As a result, water inside exposed tissues begins to vaporize. This phenomenon is called ebullition. Saliva on the tongue may begin bubbling. Moisture in the eyes can start evaporating. Fluids near the skin's surface can form vapor bubbles. However, blood inside blood vessels usually does not instantly boil because the circulatory system maintains internal pressure. That's an important distinction. Your blood doesn't suddenly turn into steam throughout your body. But exposed bodily fluids behave very differently in a vacuum. Part 4. The oxygen problem. The most immediate danger isn't boiling, it's oxygen deprivation. The moment you're exposed to space, you stop receiving oxygen. Many people assume they would instantly lose consciousness. That's not exactly true. Your blood still contains some oxygen. Your brain can continue functioning briefly using the remaining oxygen supply. For approximately 10 to 15 seconds, you may remain conscious. During those seconds, you would likely experience severe shortness of breath, dizziness, visual disturbances, confusion, panic. As oxygen levels drop further, unconsciousness follows rapidly. Once the brain is deprived of oxygen, survival time becomes extremely limited. Part 5. What happens to your lungs? One of the biggest mistakes an astronaut could make is holding their breath. Why? Because expanding gases can damage lung tissue. When pressure suddenly drops, air trapped inside the lungs expands dramatically. If someone holds their breath during rapid decompression, the lungs may rupture. Air bubbles can enter the bloodstream. This can create life-threatening complications. Astronaut training specifically teaches personnel to exhale during emergency decompression scenarios. The goal is to allow expanding air to escape safely. Part 6. Would you freeze immediately? Hollywood often shows people instantly freezing solid in space. Again, that's inaccurate. Space is cold, but heat transfer works differently without air. On Earth, cold air pulls heat from your body. In space, there is no air. Heat leaves primarily through radiation. This process is much slower. You would lose consciousness from lack of oxygen long before freezing becomes the major issue. So no, you would not instantly turn into an ice statue. Part 7. Would the sun burn you? Space introduces another danger. Without Earth's atmosphere, harmful solar radiation becomes much stronger. Ultraviolet radiation and other forms of cosmic radiation can damage tissues. However, during a short accidental exposure, oxygen deprivation would still be the immediate threat. Radiation becomes more important during longer exposures. That's one reason spacesuits provide multiple layers of protection. Part 8. Real accidents and testing. Scientists don't intentionally expose humans to space without protection. However, accidental decompression incidents have provided valuable information. One famous vacuum chamber accident occurred during astronaut training research. A technician experienced rapid pressure loss. He later reported feeling saliva begin to bubble on his tongue before losing consciousness. Fortunately, emergency teams restored pressure quickly. He survived. Animal studies and controlled vacuum experiments have also helped researchers understand the effects of low-pressure environments. These studies demonstrated that survival is possible if repressurization occurs rapidly. Part 9. Can you survive vacuum exposure? Surprisingly, yes, if exposure lasts only a short time. Research suggests that humans can potentially survive brief vacuum exposure, lasting less than about 90 seconds if rescue occurs quickly. The critical factors include duration of exposure, speed of repressurization, prevention of lung injury, rapid restoration of oxygen. The longer exposure continues, the lower the chance of recovery. Brain damage becomes increasingly likely after prolonged oxygen deprivation. Part 10. Why spacesuits are so important. A spacesuit is much more than clothing. It's essentially a personal spacecraft. Modern spacesuits provide oxygen supply, pressure regulation, temperature control, radiation protection, communication systems, carbon dioxide removal. Without these functions, survival in space would be nearly impossible. Every component serves a critical purpose. Conclusion. So what really happens if you're exposed to space without a spacesuit? You do not explode. You do not instantly freeze. But you face a deadly combination of oxygen deprivation, pressure loss, swelling, and fluid vaporization. You may remain conscious for about 10 to 15 seconds. Your body begins swelling. Moisture may start boiling due to low pressure. And without rapid rescue, unconsciousness quickly follows. The vacuum of space is one of the most hostile environments humans can encounter. Yet understanding the science behind it reveals something incredible. The truth is even more fascinating than the movies say. If you enjoyed this deep dive into space survival science, hit the like button, subscribe for more medical and science breakdowns, and share this video with a friend who loves space mysteries. And tell me in the comments, would you ever volunteer for a mission to Mars? See you in the next video. Thanks for watching my video, and please subscribe my YouTube channel.